Hi, GERO 200. How are you? Summer 2020 is June 1st, and it's time to start week 2. Okay. Sure you're excited about that. So, yeah, so we're gonna we've set you up now in terms of understanding um, the brute force numbers and how that's going to impact nations around the world, how it impacts our country. We kind of gave you just a little focus group exposure to how it's going to impact your ability to afford housing, and also just the issue of affordability in housing and how that affects elders, and how that's going to play out in terms of your responsibilities. Okay, so what we're going to do now is going to go into week 2 right here. So we're going to go into the weekly assignments. All right, awesome. Again, we lay it out here in terms of what it is you have to do, and so this was just global populations, generations, and our populations here in the U.S. And we can sit there and watch TV, watch CNN right now, and we can see how being politically active is a generational thing. We don't see a bunch of old people out there protesting. We see young people, all right? And that's just the nature of the beast. We pass that baton on to you guys because you have more energy. All right. So we see here that we're going to have 1, 2, 3, 4 sessions on biology. And again, I know you're not biologists, don't freak out. So this is all very valuable. It'll give you a better understanding of why we're aging and why we're vulnerable to the diseases that then again made us vulnerable to COVID-19. So we're going to get into that here. We'll go over cancer, diabetes, um, and then we'll get into the metabolic syndrome where with diabetes you have heart disease, and then we'll see how that puts you at risk for Alzheimer's. All right. So they're all interconnected. It's really useful information. And from there, we launch into more applied aspects of aging, caregiving, economics, retirement planning, legal aspects. Okay, so it's a really, real cool course, guys. All right, so let's get in here to this week. All right. Okay, so again, my video is going to go right here. Alrighty, so we give you this theory on aging, and then we want you to kind of we use one approach to applying it to real life, and that's fertility issues, okay, and reproduction. And yeah, it sucks, your egg and your sperm are in their prime right now. All right, I always pose the same question. How many kids do you guys have? So you guys are 18, 19, 20, 21, 22, you really realistically should have 4 or 5 kids. That's what biology says, okay? But that's not what we do in terms of society, okay? What we do is we try and get our act together. It's exactly what Julia and I did. I met her, she was 20, I was 27. We should have been bada bing, but we didn't. We had to get our act together. We had to create our careers. We had no family support for finances, so we had to create our own support for finances, and it took us a while. So we dated for God, almost 4 years, and then we had our first child 8.5 years later. Okay, which made me a much older dad. So I was 39, and Julia was close to 32. Okay, so and that's what happens. Not there any right way. That was our way. Okay. So yes, and so we're going to go what happens to our eggs and sperm and why we all run into fertility. So what you guys will often find, and this is the nature of the beast, is you put it off and you put it off. God forbid you get pregnant. You wait and wait and wait and wait. Then finally, you're in your 30s, you say, okay, I am ready. And lo and behold, biology says, sorry, you're now infertile, and it's because of the basic aspects of biology that we're going to talk about right now. Now, before I launch into this article, I'm going to download it and we'll kind of go through it real quickly. Um, Julia put up this figure right here. These are the major theories. We're going to go with some other things. There's a lot of overlap and they all interact, and that's what the arrows mean. Now, I'm going to, why scientists have to speak in a foreign language is beyond me. So this is a big theory, the antagonistic pleiotropy theory. Okay, what we should call it is what's good for you now may not be great for you later theory. That's all it means. That's all it means. Okay, so a classic example is we put all of our nutrients in to the cells, and we say grow and get big and strong and go freaking reproduce. Okay, all right. That's what it's all about. Grow, 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 and get more nutrition and grow. Okay, good to the point of reproduction. But unfortunately, those same signals, there are biology. And if you keep doing this, yum, 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 eating all the goodies, you're in your 30s and 40s and 50s, okay, guess what happens? Those growth signals then become growth signals for heart disease, diabetes, cancer, and all that, right? So what's good for you now, when you're 18, you're buffed, you're reproducing, not so great for you when you're later, all right? Another example of antagonistic pleiotropy, I'll throw it out there, is having a really hardy immune system that will just kill off every bugger that gets in your way, okay? So that's what we want. Viruses and bacteria and fungi and parasites. They're all trying to pirate us. So the best thing you do is have an immune system that's aggressive. All right. So that's awesome. Okay. In fact, women have. I just wrote a paper on this. Women have such an aggressive immune system. We're wimpy, you guys, compared to women. And it's all genetics. It's all played out with their X chromosome, with estrogen, everything else. So they get sick less often, and when they do get sick, bam, they slam it. That's the double-edged sword, antagonistic pleiotropy. It means that their immune system is aggressive on their own body. So who gets autoimmune diseases? Okay, all righty. Autoimmunity down here should be part of antagonistic pleiotropy. Women get autoimmune diseases about 8 to 1, 9 to 1, depending on what you're looking at. Poor Julia has a couple, and it predisposed her to getting leukemia as well. So yeah, so it's a double-edged sword. We're even finding right now with this COVID-19 thing that the problem with the immune response is it's so aggressive because it's got to kill off the virus that it overshoots its mark, and that's causing a lot of damage to the lungs and the heart and creating disease unto itself. Okay, so we're not perfect. All right, what else? We have waste accumulation. All right, this happens when you have damaged proteins. It's like trying to stuff something down a garbage disposal and suddenly it doesn't fit anymore and it accumulates. Right, this happens in plaques and tangles and Alzheimer's disease. Okay, it happens in these big clumps of proteins in Parkinson's disease. It happens in amyotrophic lateral sclerosis. Okay, on and on and on. Okay, it happens in heart disease. Okay, so this accumulate. We're supposed to, and you guys don't realize it, but all freaking day long, you are making new proteins and get rid of the bad. In comes the new, out goes the bad. In comes the new, out goes the bad. That's why you have to eat all the time. Okay, you need protein because you got to replace the stuff that you just shoved down the garbage disposal. And if you don't have a really efficient garbage disposal, guess what? Stuff builds up. All right. Why do proteins get old and screwed up? One way is free radicals. Okay, you've heard of them. Okay, what do you take? You all do your antioxidants, your green leaf. A bunch of you people are kale people. Okay, why are you eating kale? Okay, it's because of the antioxidants that are in there that will eliminate this oxidizing element called a free radical. Where do they come from? Where do these free radicals come from? Okay, they can come from overnutrition, okay, stimulating free radical generating pathways. They also come from really old, effed up, that means screwed up, mitochondria, okay? Our mitochondria inside our cells, they take in the oxygen, they take in the glucose. It's just like your car engine, and whoosh, they produce heat and energy, and they get things done, okay? And just like your car, if you have a 35-year-old car, it's not very efficient. Well, the same thing happens with mitochondria. It starts spewing out these free radicals that then cause proteins to get all screwed up, and then they accumulate as waste. All right, what else? Insulin resistance. We get older. Sadly, our insulin receptors do not work as well. So what happens is you take in a Snickers bar, all that candy comes in, your pancreas says, we gotta get rid of this stuff and put it in out of the blood and put it in the cells, right? So it relieves insulin in response to all that glucose. And then the receptors say, hey, here comes insulin. The receptor goes, okay, opens up, and then all the glucose goes flying into the cell. And voila, you don't have any glucose inside the blood. That's good. You just use it as you need it. Okay. When you have insulin resistance, that doesn't work. Okay. So you don't get goodies inside the cell. So you start eating more, going, where in the frick are my goodies? Okay. and then the goodies accumulate out in the blood because they're not going in, and then you get this thing down here. Why can't we speak in English? Advanced glycation end products. That's the acronym is AGE. It causes us to get old. Okay, what is advanced glycation end product? It's this sugar attached to proteins. Okay, if you have a ton of sugar in your blood and you're not getting it out, what happens is the sugar comes in, boom, it sticks to a protein, and now this protein's all you can't work. Okay, and it's like that until you get rid of it, but you can't get rid of it. Okay, that's what that is. Okay, it's like candy coating a ham. All right, telomeres. Okay, all right, this is the level of cell division, and they get all screwed up. All these problems up here, okay, insulin resistance, free radicals, screws with your telomeres as well. You get more mutations. Suddenly your eggs and your sperm are all tweaked. And guess what happens? You get more birth defects as you get older. All right. All righty. All this, but you get an error catastrophe. All these errors and problems, they build up. Suddenly the cells go, and that's it. Right. All righty. And then in the end, evolution says we did this on purpose because we want you old guys to get the hell out of here. Okay. All right. Because we want to have young sperm and young eggs so that we have a perpetuation of the species that's vital. All right. All right. So that's what that's all about. So that's a quick overview. All right. So let's take a look at the PDF file here. I'm going to get out of the way here. Sorry about that. There I am. Okay. All right. So just read through this like you're reading through a real fun read on Twitter or something like that. Don't get caught up on it. All right. Don't worry about the details. Do remember though, as you're doing this, that the best thing to do, sorry, is just scroll down here. I just opened it up. And here it is. Open your quiz at the same time and answer the questions. All right. What kind of quiz am I going to get today? All right. Let's see. Begin. All right. Okay, what is the effect of raising flies in a high oxygen environment? Sounds like a lot of free radicals, reactive oxygen species. Okay. All right. Is it gonna speed up the metabolism? It's gonna shorten their lifespan. Poor guys, because it's free radicals. Aging is not programmed. It's influenced by evolution. Okay. It's linked to mitochondrial function. Okay. It's all the above. All right. So figure that out. All right. Anyways. All right. Back to where I was at. All right, here we go. All right, so here's all the theories on aging and explains, what's going on. Okay, there's a lot of belief, and there is some truth to this. That if we can modify the course of aging, and you also modify the course of getting diseases. Okay, sadly, you're still going to hit a tailspin. So we can push it back so that, man, you are the most vital. Before, people would get in their 60s and they would have all these problems, and they would die. But now, man, 80 is the new 60, and 90 is the new 60, or whatever it is. Okay, so ultimately, you're still going to have this senescent downward spiral period of life, but we're trying to just kind of compress it so it happens real quickly and you don't have this morbidity or sickness that extends for 15, 20 years. All right, that's what we're trying to do here. So if we can modify the course of it, one of the best things you do is don't eat so damn much, right? Restrict your calories, okay? It takes the foot off the gas pedal, the free radical generation, okay? It allows you to repair your body in a much more efficient way. It's boom, 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 boom. If you have a bunch of nutrition, okay, your body says, hey, here comes all the goodies. I'm going to secrete a bunch of insulin, okay? And I secrete this growth factor. It's called insulin-like growth factor 1, okay? Sorry, I'm trying to highlight it. There it is, right there. Both of them not only help to package away the food, but they tell the cells, hey, do you see all those goodies? Let's divide, let's divide, let's divide, let's divide. And then the alter ego is when there's no goodies around, hey, let's hunker down and repair what I got. Let's make sure my DNA is clean and there's no mutations and things like that, right? So it's a balancing act, okay? Again, antagonistic pleiotropy. We need a lot of growth in nutrition for growth when we're growing up. We don't need it when we're older. So we got to restrict our calories a little bit, exercise, stuff like that, right? So that's what that's all about, okay? If you got too many goodies around and you're not using them, what do you get, okay? these glucose molecules stick to proteins, and you get these ends, glycation, end products. All right, exactly what I talked about earlier, and they are nasty. They damage the proteins. They're there for super long period of time. Not good. All right. All right. So one of the things happens when you got the sticky sugars and you got you got all kinds of oxidation, and when you pull, it's like me pulling my hand off. I'm gonna be like, oh, and then you come from this cross link to give me some stability. So you get these cross links again where the proteins accumulate, but they're odd and they're non-functional. All right. All righty. So here we go. Here's this concept of antagonistic pleiotropy. What's good for me now may not be good for me later. All right. So we get over the evolutionary aspects. Hey, there's our friend the mitochondria. Remember, they go bad. Best way to have mitochondria that are good, you limit the amount of food you take in, stimulate your cells to make better mitochondria. Yeah, it turns over the mitochondria. Right. You exercise. All right. It stimulates your cells to have new badass mitochondria. Alrighty. So all these things that are going on that are potentially damaging or protective, we have to maintain our DNA. All right. The DNA is our cookbook. Right. You're going to make new proteins. You better have a good cookbook. If you have recipes that are screwed up, you start making bad proteins, and guess what's going to happen? You're not going to be your souffle is going to taste like crap, and you're not going to be very vital. All right. So that's why we have to do this. Okay. Here's endocrine, and it talks about, again, this is the growth hormone stimulated when you have too much nutrition, right? So always trying to reduce our AGF1, reduce our growth hormone as well. Those are the big ones, okay? All right, we also lose certain aspects of burning calories like testosterone and estrogen, and that's a whole different story. All right, here's this oxidative damage, free radicals. I'm gonna eat acai berries, okay? That's what I'm going to do so that the oxidation is not going to get me. I'm going to eat my kale, okay? Alrighty. And then supporting this, they say the rate of living theory. Okay, what that mean? What does that mean? When I look at Bella, hey, Bella, come here. Oh, well, my dog. She's not going to live as long as me. You know, come here, 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 come here. All right, come here, come here. All right, we're going to show you Bella. All right, there's Bella. Now, Bella, look at how gray she is, okay? Bella's 11. If I was that gray when I was 11, I'd be kind of bummed out, but she's doing good. She's approaching 80 as a dog, okay? And if I were to stick my ear up against her heart, instead of going 60 beats per minute, she's going like 120 beats per minute. That's the rate of living. She's pumping out the free radicals, burning oxygen, and you get free radicals. If I put my ear on a little mouse heart, it goes 300 beats per minute. Okay, so every time the heart beats, you're burning oxygen, and sometimes you're not good at it. All right, and so you generate free radicals, and that's what that's all about. All right, so what else do we have here? All right, so this is our ability to produce new cells. You know, why is it that my skin's all saggy? Okay, here's a demo. All right, so look at that. No, I'm doing good. What happened? Get back up there. Okay, so I don't produce skin cells the way you guys do. All right, this is what it is. That it limits our stem cells everywhere. Okay, and that's because every time your cell divides, there's a little time clock called the telomere on the end. It gets smaller and smaller and smaller, and that determines how many more cell divisions you have. Every division, every day you're alive, you have one less division ahead of you. All right. And it slows down the cell division. That's my issue right now. All right. So yeah, so these are all big theories. Awesome. See, I gave you the overview. It's very cool. All right. Now the cell division theory also applies to old eggs and sperm generators. Okay, and that's what we're doing down here when we get down here. So we're going to go into the discussion. So I want you guys to really think about this. All right. This is a cool website. It's private. And then this right here is a support group that talks about fertility. And we go into movies, little videos about IVF and what it's all about, in vitro fertilization. That's the last straw. It's expensive. First of all, you're going to be trying to become a super ovulator. All right. All right. So let's take a look at this. All right. So we're going to go to this fertility website. Okay. And the way it works is, yeah. I don't want to read more right now. Sorry. I'm going to get out of you. You guys look like wonderful doctors, though. All right. All right, and we used a fertility doctor to get our second one on board. You know, that's because we waited so long. I was like late 40s. My wife was 39. Well, you know the drill. All right, I'll show you the drill. So these are all ways to investigate this. Okay, so you click on it, and this is what I want you to do. All right. All right. First of all, okay. All righty. What did I say here? All right. You guys are prime time for fertility. Okay. All right, you wait for your job, you finally feel like, hey, I'm ready, and look at you, your fertility rate is half of what you used to be, right? Or you wait to like here, where like we did, and we we weren't doing so well. All right. Why is this happening? Okay, why is this happening? Well, you guys are born with your full allotment of eggs. As they hang around, they accumulate damage. Okay, they don't divide as well once they're fertilized. It is what it is. Okay, all right, so this particular website, you go back here, okay, focuses on women, all right? But don't forget, guys, you play a major role, especially in terms of a lot of diseases. We're talking about a lot of mental health issues that are linked to sperm age, okay? All righty. So what is the whole interaction? Okay, this is your brain, all right, right here. This is your pituitary gland, okay? All right, it releases, okay, follicle stimulating hormone right here. See, FSH, it goes down here, and it stimulates your ovaries where the egg is. The egg is housed in this thing called a follicle, okay? All righty, and the bigger it gets, the more estrogen it secretes, and then it goes back, and see that negative sign right there? It tells your brain and pituitary, that's it, shut off. And what do? That's your cycle every month, all right? The interaction between your ovaries and your brain, ovaries and your brain. Okay, that's how that works. Now, what we find when we get older is we can, first of all, test your blood. And because your eggs are getting so old, okay, and the follicle, that's a cell division issue, doesn't divide to make a good follicle, so you're not producing enough estrogen. And so we're going to see that your blood FSH levels are going to be higher if your follicles are all screwed up. Right? So that's one test that your doctor's going to do. All right. What else are we going to do? We're going to see whether or not we can give you a bolus of FSH and make sure that you do make some follicles that will actually cause that egg to be released. All right. That's the other thing we're going to do. All right. Cool. Bam. All right. FSH. All right. So that's the hormone that I was talking about. All right. So we're going to look at FSH values when there's no live births. Okay. And you look at it as a function of age right here. All right. So the delivery rate. Okay. And we see that we have all this FSH. Okay. Okay. So the higher the FSH, the more screwed up you are. Okay. All right. You're just not producing viable eggs. Okay. That's what this shows. All right. So you want to have low levels of FSH that result in a really good pregnancy. All right. And you see the likelihood goes down, 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 down as you get older. All right. That's what that's about. Okay. It's an awesome website. Okay. More facts about FSH values. Okay. This is the clomiphene challenge test. Okay. That will often be done. Watch the video. Okay. What you're going to do is you give this drug that causes FSH to go kaboom. All right. And these are other methods of challenging your ovaries. All right. To make more eggs. All right. Again, we got to figure out what shape your ovaries are in before we start doing the second part, okay? And it discusses in that website, and it goes over it in more detail here, okay? Because this is the AmericanPregnancy.org site that I'm sure a lot of you guys are going to have to visit someday. That's the way it goes, all right? And we come right in here, and we're going to look at the medications, all right? So I told you that this guy, Clomid causes a release of FSH, so we're going to give you clomiphene. All right, it's called clomiphene citrate right here, Clomid or Seraphine. Okay, just drug company names. The bottom line is you get a big whoosh of FSH, and then that's going to cause multiple eggs to go through. Okay, it stimulates your ovaries to ovulate. In fact, what's going to happen? You're going to have an increased incidence of multiple births. it rushes through the system, so you get more miscarriages. Okay, it makes you feel like you're, going through menopause. All right, because that's what happens when you start, your ovaries stop producing estrogen, you start whooshing out the FSH. Okay, so yeah, so that's one. Right, here's another one right here. All right, this is a hormone that is actually secreted by the placenta, right? That increases fertility. All right, so that's another method that you use. Okay, side effects. Okay, here's another one. Okay, again, these are all drugs that all are based on this concept. All right, I'm done with that. Okay, but and watch these videos right here, and then look at this. All right, I'm gonna increase this. Okay, because this is important to think about. All right, so read this figure legend. Right, what does that say right there? It says paternal age. Right, all right. The older dad is, okay, the greater the likelihood of autism, ADHD, psychosis, bipolar disorder, suicide, or substance abuse, failing grades, all right, and lowered educational attainment. All right, um, so yeah, so we got issues. We got issues when our sperm gets old. It's not just on the woman. All right, cool. All right, what else we got here? I'm almost done here, guys. We have right here CT assignment 1, due in a week. Okay, June 8th. All right. So what I have right here is I have a how-to. I'm going to turn this thing on. I'm going to send it out along with this one, and it explains how to do it. All right. All right.
Today is September 12th,
It's an old
2019.
one. All right.
And the point of this video is a short instructional video on how to do CT1 right here. Your first paper, 74 degrees.
All right.
It was awesome.
Yeah, that's
submitted, and there'll be no problems. Okay. You follow directions and
all right. So go
ratio. Okay. The website's going to do this for you.
All right.
There's two different ways of looking at the data. You can look at a map where it takes you back up there, and there is the graph. But they're not replacing themselves either. Also download. It's up to you. So I think you see what's going on. It's pretty straightforward.
And I show you how to do the how to use their graphics. And again, you can just do a print screen and crop it in PowerPoint, or you can use the Windows key Shift S, and then that allows you to crop the figure that you're going to put in your document. All right, so that's it. I'll send that one out maybe tomorrow, something like that. All right, guys. All right, so I think we're pretty close to the end right now. Hope you're having a good summer, and you guys hang in there, and I'll see you next time.